Andersson, and I'm one of the technical directors in the Frostbite team here at DICE in Stockholm, Sweden. I'm here today to talk about Battlefield 4 and Frostbite and a really exciting opportunity and new thing that we've been working with AMD for. We've been working together for the last 9 years. It sort of all started back with Battlefield 2 in 2004. And we work very closely with lots of teams at AMD. We work with the developer relations team, we work with the developer technology team, and also the driver teams to optimize the drivers for all our different games. And we sort of focus on quite a few different areas. Quality in our actual game, to make sure that we actually utilize the GPUs and make sure our games looks great and runs really, really well. But also, well, standard stuff like pure robustness, make sure your games are stable at launch. AMD has quite a lot of special features that we've been implementing over the years, like Crossfire, making sure it can run multi-GPUs very nicely, or Affinity running on tons of different screens. We've had some pretty cool events that we've also been collaborating on, such as the BF4 announcement over at the GDC. We also have regular meetings with sort of key technical staff at AMD and the hardware architects. We've been doing this for years and years. And it's always amazingly fun to sit down and talk with all of the architects about future hardware, our future software, our needs, and see how they align and actually have an opportunity to affect the development on future hardware and make sure it really fits our games. One of the main things I'm going to talk about today is Frostbite. So Frostbite, and specifically Frostbite 3. Frostbite 3 is our next generation engine, and our mission in the Frostbite team here at EA is to empower our game creators and essentially just create great games. And Frostbite has evolved to become the platform across the EA for doing shooters or RPG games or real-time strategy games, as well as racing games, and quite a few more. And it's really fun to see how all these different studios have been working together and starting to collaborate and share, and we're using Frostbite as a common platform. Studios like Ghost, a newly started studio in Gothenburg here in Sweden, and they're making Need for Speed, or studios like BioWare has an epic long history doing really cool RPG games, as well as studios like Visceral with the Dead Space before, all of them working together with Frostbite. And overall we have approximately 15 games in development with Frostbite. Dragon Age Inquisition is a massive RPG made by BioWare. Plants vs. Zombies is one of my, Garden Warfare is one of my absolute favorites, made by PopCap. And then we have the games we're working together with Lucasfilm on, and the Star Wars franchise is really exciting, such as Star Wars Battlefront. Command & Conquer, a legendary franchise, an RTS game. Didn't really think that was possible in Frostbite, but yes, it's definitely possible. Need for Speed by Ghost and Criterion. Mirror's Edge, a beloved franchise that we're working on here at DICE. Mass Effect, one of my most favorite sci-fi games. And of course Battlefield. And I'm primarily going to talk about Battlefield here this time. So I'm just going to do some quick highlights about Battlefield and some of the key features of it in Battlefield 4. So Levolution is a new concept that we have in Battlefield 4, which is how you can affect entire levels, how you can have a giant skyscraper based on player action completely fall apart and affect how the gameplay is done for the rest of the round on that level, or how an entire level gets flooded while you're playing it. It's pretty awesome to play in an environment and seeing that happen. We also have spent a lot of time working on a cool solution for network border simulation that we're using in our multiplayer, as well as the single player. So you can have a 64-player match of people racing around in boats of various types and aircraft, and all interacting with the water. A key area for us has always been VFX, which things like destruction and just particles in general, and we're continuing to push forward there in Battlefield 4. And a key part of this also is something we added back in BF3 that we refined further, is to utilize compute on modern GPUs to do our lighting inside compute chambers. So we can have lots of particles and light sources all interacting and creating these really dynamic and visceral environments. And to top it all off, once we have our rendered pictures, we have a lot of different post effects, and we've been improving this quite significantly in BF4 of doing bokeh depth of field, skin subsurface scattering, and a lot more accurate velocity object motion blur, as well as super sampling for absolute highest quality rendering. From a tech point of view, we've really optimized the engine for DirectX 11.1 and for Radeon GPUs together with AMD. We've been working closely on this for quite some time, both on the CPU side and on the GPU side. Optimizing shaders and optimizing various rendering techniques, or just helping to improve parallelism in the engine. And we also managed to get Microsoft to add some really good optimizations in DX 11.1 that improves our CPU utilization further. This is active when running under Windows 8. And for the first time ever for Battlefield, we're doing a 64-bit native executable for the game when you're running it on a modern CPU. This improves performance, especially on our highly vectorized code, such as the water that I mentioned, and in general allows you to access a lot more memory. And we're also spending quite significant amount of time parallelizing the engine further in order to scale up to 8-core CPUs. And this scalability also, well, affects graphics overall. We can scale running the game from anything on like in the APU on the lower end side to a big multi-GPU system. So we've been focusing on building a lot of scalable solutions inside Frostbite that all of the artists and level designers have been using to great effect. PC in general is really an amazing platform, I think, to work for, and has a lot of really unique strengths. You mentioned the scalability of going from the absolute lowest end to the absolute highest end, like in this case, our dual 7990 machine as a really high-end quad GPU desktop. A DICE PC is really in our DNA, I would like to say. It's sort of where we come from with Battlefield 1942, which was a PC-only multiplayer shooter that we owe our success to. And we as a studio strongly believe in and will continue to support PC as a gaming platform. But there are a lot of challenges on developing on PC also and releasing big games as what we're doing. One major one is performance. I mentioned the scalability aspect. There's also lower level aspects of how you work with DirectX 11 or OpenGL. It can't really utilize all the CPU cores with your rendering, which is a big problem for us. We want to have really complex scenes, lots of draw calls, lots of interesting dynamic environment, and this is a significant bottleneck. From a programmability point of view, PC is, well, it's easy to develop for on the CPU, but programmability when it comes to GPU is quite difficult. It's sort of still stuck in a model where a traditional model where the CPU is essentially spoon-feeding the GPU with commands, and memory is something that's hidden away from you. That makes collaborating between the CPU and GPU very, very difficult. And also, not all functionality of modern GPUs is exposed. Another key challenge on PC is the hardware and software abstractions. Having abstractions is really necessary because, well, you need to be able to have a scalable PC. That runs on different hardware, different graphics cards, and different CPUs, and different memory, or different form factors for that matter. But these abstractions are really coming in the way for us quite a bit, getting in the way for us quite a bit. We want to be able to adapt our use cases and our game engine to what the hardware is capable for, not sort of limited based on just what the software allows us to do. We have a lot of information in our engine and a lot of knowledge about our scenes because, well, we're simulating these entire game worlds. We know what we're going to render. We know what will happen, well, not all the time, but we know ahead of time. We have a lot of really important information that we can base high-performance decisions on, things that we can implement more efficiently if we were able to, things that the OS or the graphics driver or the API can't really predict and has to go through a slower path for. And we're also feeling that these APIs that we're working with on PC and these abstractions overall, they're not really evolving fast enough for us. And all of this together sort of limits the type of game scenes that we can create on modern CPUs. So, as a contrast, on the consoles, we, of course, develop then only for a single specific system setup and system configuration, where we really know the hardware components. And almost all of it is exposed to the developer, which is really nice. And you combine it with a low-level overhead and very thin graphics driver, and explicit control for us to memory, where we can explicitly control memory, makes it a lot easier for us to develop and work on the consoles and target and actually achieve the target frame rate that we're trying to get to. And we have lots of experience doing this on, well, both the previous generation consoles and the new generation of consoles. So what we really want on PC is to be able to, we want to be able to push the sort of PC industry forward and make awesome games. have these massive dynamic and immersive worlds with photorealistic visuals, and not be constrained by software limitations. Want to utilize the hardware fully. So what we want is sort of the best of both worlds, the best of PC and the best of console, while at the same time keeping scalability and the ability to run on tons of different types of PCs. So what's required, in my view, is a quite different approach to graphics APIs and drivers. A different approach where the game engine, Frostbite in this case, takes on a lot of responsibility that the graphics driver currently has today. And the graphics driver becomes more of a thin abstraction layered on the hardware. The key aspect there is that we really need to have control over memory and hardware components. So I've been talking about this type of approach for years with the various graphics vendors, and I'm finally really happy to be able to announce and be able to talk about that we're working with AMD on a solution for this, and it's called Mantle. So Mantle is exactly what I wanted, a low-level, high-performance console-style graphics API for PC, for Windows. Yay! It's being built by AMD in close collaboration with us, and it's the direct result of these discussions that we've been having. And the intention is going to be cross-platform, which is really important for us, but Windows initially. And Battlefield 4 is the pilot project and sort of first use case of Mantle. And the key idea there is for gamers to be able to get absolute best performance when running on AMD hardware. So what we're building in Frostbite is a native rendering backend using Mantle instead of DirectX for Windows. And the idea is that this will be used when having a compatible Radeon GPU and having this enabled. It's being developed right now with AMD and myself here at DICE. Some of the things that this will enable is for us to be able to get really superb CPU performance in Battlefield 4. We have very low overhead rendering with Mantle, as well as how we load our levels and how we stream content in general. We can render everything in parallel on the CPU. One of the key limitations of DX and GL, and this can be, we hope to be able to get perfectly linear scaling here and utilize all 8 CPU cores. And this will enable us to sort of avoid bottlenecking the game and the engine on just sending commands to the GPU and the overall system for that matter. We'll also be able to get really highly optimized GPU usage because we have full access to all of the functionality of the GPU, and that enables a lot of different, a lot of various low-level optimizations. And this is really a foundation for the future for us as well. And only the beginning. We have lots of Frostbite games in development, as I mentioned, and these are some of the key initial use cases that we have. We have a lot of ideas going forward. So, to summarize a little bit about Battlefield 4, it's going to be launched in end of October. We have 64-player multiplayer. While we're developing this highly optimized Mantle renderer, Battlefield 4 will, of course, also have a DirectX 11 renderer, which is the main one that we'll be launching with in the end of October. And we also have great Crossfire and Affinity support. And then in December, we'll be releasing a update for Battlefield 4, which contains the Mantle support. And we're super excited about that because that's the first time where gamers will be able to get the absolute most out of their PCs and their Radeon GPUs. And we should be able to see some really good performance improvements with that. And it's a free and automatic update, and I hope you all will enjoy it. So, going forward, I'm super excited about Mantle, and I'm looking forward to be able to share more details about it in the upcoming months. We have tons of ideas of how we want to be able to utilize this. Everything from being able to have a really low latency multi-GPU renderer for VR, to be able to do game worlds that sort of lived only on the GPU and then updated there with all the teraflops of compute capability that you have. I'm really looking forward to investigating and talking more about all of this. So, thanks.